and we'll go to our next speaker, Steven Varga, who will be talking about Idiomatic MPI for modern C++.
Thank you very much. This is Steven Varga speaking here. And let me try to share my screen. All right, this is about MPI and C++, and there is a connection to HDF5, and that's why I brought this idea before you. I am Steven Varga. I am an independent researcher, also the author of a different H5 CBB than the previous presenter talked about. And tomorrow I'm going to have a brief presentation on that version of the H5 CBB. So what I'm going to present here is an idea that MPI can be simplified in the context of C++. And what I'm going to go through is the syntax, the proposed syntax, some features, and how it can be integrated with HDF5 or parallel BLAS Scala flag. It's going to be a little bit technical here. What you see on my screen is a software snippet borrowed from MPI tutorial, and an entry and an exit point of code. And what I'm going to walk you through is what simplifications can be made and how we can achieve a more idiomatic MPI from a C++ perspective. So what you can see is an MPI init, and at the exit we can create a mechanism that automatically will call MPI finalize, and that's a good thing. It reminds us to our AII pattern in C++. We don't have a dangling case when we don't call MPI finalize. Now this is it gets a little bit dense here with the MPI ASN call, where it can take complex objects, path types, standard template library calls, and linear algebra objects, numeric types, strings, and whatsoever, and do the right thing. Now, there are details here, and there is a mechanism already implemented in a different project that I mentioned in H5 CPP, and tomorrow I will talk about the mechanism, the underlying mechanism that actually allows to make this one happen. But all in all, it turns out lots of features that I worked on a previous projects could be imported into this idea of having a C++ MPI, and it will just do the right thing. What we can see here is a different pattern where we make an MPI call and retrieves an object, and how it actually looks syntactically, such as like template specialization here would trigger the reader, what object, what types we're speaking of, and there are optional tags or optional information or sideband information, much similar that we are familiar with in Python. In this case, the implementation would be template metaprogramming based. There is no runtime trade-off. Similarly, there is an efficient IO calls for a given function. In this case, it doesn't require the object be created, but you can create the object. This way, you can save memory, significantly reduce stress on the stack. Let's take a look at this original C call for a scatter operation. This is a collective call. It's another way to look at MPI, and this is the complexity of the original call. What we can actually see here that the data received on the left-hand side that's created on the stack, and there are some details, but most of these details can be totally omitted. Similarly, following up, the returned values are actually the rank size vectors here. So for all the ranks, that actually follows up and does whatever the writing supposed to be. So interactions with other systems, such as HDF5 and parallel BLAS. With the HDF5, we can signal the MPI call. We already have property list with these ones that can be picked up from the underlying systems of ranks and all the details. The data transfer, the size, and then the cons and the patterns can be signaled with sideband information such as the offsets and the cons, and linear algebra objects can be supported easily, and the hows will be discussed tomorrow. And finally, we can actually call the routine safely, directly, and then collect the results. So how this idea can be done? It turns out, as I mentioned previously, most of the work that I've done on a H5CPP can be recycled, such as the type system, the static reflection system that allows you to do these ones automatically or currently with a bit of an assistance from the LLVM framework. Handles and identifiers can follow a similar RAII pattern, which means like binary compatible with the original system. Daisy chaining properties are similar to HDF5. The intuitive Pythonic syntax can be mimicked, and creating a similar experience that you are already familiar with Python, possibly Julia MPI implementation. Feature detection idiom of the C++ may be used to create a mechanism to support standard template library like containers. Another way to say any of those objects you already have created or worked on, if they are familiar or similar to standard template library, then it will just work out of the box. Many other features can be discussed here, but short of the time. I'll just get straight to the point. So how can you help? By providing some feedback. If you like the idea, just select thumbs up. And if you're not so much, just pick up the less smiley face of the wow, and we can take a look at it later.
Thank you, Steven. We should go to your next talk in the sake of time. Thank you.